welcome to electrical site in your course. The topic for today is how we can read the single line diagrams and how we can read the load schedules. So for single line diagram, it is basically a diagram that shows uh, a three-phase system in just with a single lines and can show the flow of current or the flow of power. So this is a basic single line diagram. I will show you even more single diagrams, but just look to this one. We have At this stage, we have here the transformer, and from the transformer, some tap off units are there for the fire pumps. As you can see, here we have the 30 horsepower fire pumps. So we are directly taking from here with these circuit breakers. That is 400 ampere frame, 480. Here is 480. Here is 880, and we have the 880. So these are the ampere ampere rating of the circuit breaker. So that is also shown in the single line diagram, and then we have that is coming to these fire pumps. Why are we taking it before the main distribution boards? Because we don't want any tripping to happen in this main distribution board. That's why we don't want to pass it through this whole mechanism of the main distribution board. We want to take it directly from the line that is coming from the transformer. Then we have the main distribution board. Okay, here is the main distribution board, all of this one, and we have then the feeder circuits. These are feeder circuits. Okay, as you can see, these are feeder circuits. With each feeder circuit, we have one motorized uh, circuit breaker, that is MCCB. Here we have the motorized circuit breaker, here also. So all of these are motorized circuit breakers. Here we have 110 volt DC supply, and here is the kilowatt hour meter. We have the surge protection device here. Here is the uh, voltmeters or voltmeters are here. That is showing line 1, line 2, line 3 voltages. Here we have the incomer is from the top, and here we have a motorized ACB. Okay, this is air circuit breaker, and in each circuit we have then one kilowatt hour meter, or okay, we have here 1 kilowatt hour meters that is showing how much power is passing through power meter. Here they are showing. So this is how you have to read the single line diagram. Let me show you another single line diagram. We go to here. Where is it? Even in previous lecture we have covered this one, but as you can see, here we have the 33 kilovolt cable coming from SEC, and then we have the ring main unit, then we have the drive trap transformers. All of its ratings are given here. Then we have the main distribution board, and from main distribution board is going to sub main distribution board. This is the incomer, and these are the feeder cables. Then we have the incomer and the feeder feeding circuits. Okay, so this is how you have to understand the single line diagram. For example, here we have the generator. This is the ATS. For the ATS, one line is coming from the main distribution board here from the normal supply, and one is coming from the generator for the ATS. If there is no power from main line, then the ATS will transfer the power to generator, and then generator will turn on, and generator will energize the emergency distribution board. But if there is power, then the main distribution board, this one, it will power the emergency main distribution board. And from the emergency main distribution board, we have the emergency sub main distribution boards. Also, we have the UPS that is connected with the emergency main distribution board. For UPS, we have two cables. One is for the its inverter, and one is for the bypass switch. If we want to separate the UPS connection, uh, for example, if some maintenance we want to do it here, then we disconnect this one, and the bypass switch, it is connected with the other line, and so the end loads, they don't get disturbed, but only the UPS is disconnected here. So this is how a load schedule, a single line diagram is read. And then the next one we have the load schedules. There will be the load schedule can be made in different formats, but almost uh, all of the data here that will be the same. For example, this is load schedule panel for RP1C. This is the name, this is the voltage, this is the ampere. Here we have the short circuits withstand amperage. Then we have the incomer circuit breaker, 90 ampere tripping and 125 ampere frame. Then here we have the incomer cable size, that is 70 mm, and here the loads are given. It also have the other part, and this load schedule I also showed you in the previous lecture. And here we have all the circuits. This is L11 for the red, this is L12, L21 for the yellow, and this is one for the blue. Red, yellow, blue. Then we have red, yellow, blue. Then we have red, yellow, and blue. Okay, so we have some spares here, spare here, and here is the load connected load, how much load we have connected to this circuit. And here we have the demand load. For example, if there are 10 lights connected, so maybe out of 10, 7, 8 or 6 will be turned on, or if all 10 lights are there, maybe only for the night time they will be turned on. So this is the demand factor, that is about 0.8 or 0.7 of the time. Okay, then we have this is phase, that is single phase, and here we have the type of circuit breaker attached to this circuit, that is RCBO. Then we have the rating of that circuit breaker, and here is the fault current rating, that is 30 milliampere. If 30 milliampere difference comes in the line and neutral, so this RCBO will trip and indicate that the current is flowing or leaking somewhere else. Then we have the short circuit. It is 10 ampere here, here 15, and here 25 ampere. Then we have the length of the cable, and we have the voltage drops if any, and then we have the cable type. Okay, this is copper, XLP insulation, and low smoke. This is low smoke, and the type is 0.6 to 1 kilovolt, and this is the size 2 core to 2.5 mm. Okay, and we have a separate 2.5 mm square. So this is how we have to read the load schedules. And here we have the total connected for this panel. This is the total connected load. We have 15%. In every panel you will have to keep spare for 15%, that is for the future. Then we have the total demand load, that is coming from here, and then we have the total demand current. From this total demand current we can calculate how much cable size we need. Okay, for the designers when they are doing the design, from this total demand current they are specifying what kind of cable they need for that one. Then we have the demand factor. As I told you, for this panel we have the demand factor of 0.75. It means 0.75 or 75% of the connected load will be turned on at a time. Then we have the power factor. Power factor is actually uh, the division of real power divided by apparent power. Real power only includes the resistive loads, and apparent power includes the capacitive and inductive loads as well. So in that case, when we have a capacitive and inductive loads attached, they work as energy reservoirs. Capacitor and inductors, they work as energy reservoirs, and they give energy back to the circuit, because of which there the current waveform and the voltage waveform they lag from each other, and because of that more current is drawn into the system. That is why the power factor is always less than 1, and we want to make it more close to 1 so that the system they don't draw any current from here. Okay, so this is the power factor. We want to keep it close to 1, maybe 0.8, 0.9, and this is how you can read the load schedules. If you have any question, you can always ask me. And thanks for watching this video. Thank you so much.